All right, so on this quick lesson, we're going to be learning about two things: electrical power, but we're also going to learn about mechanical power. Oops, that's supposed to be an E. Mechanical power. And power itself is just how fast are you using energy. So like how fast do you use energy? That's what that's about. So the more power you use, the more power something is using, that means the faster it's using energy, all right? Um, so this particular equation over here, power, and then you could put like a little E to show that it's electrical power, P, power, is equal to, and so this is a real easy one, I times V, current times voltage. So current in amps, right? Current in amps. And then this right here, everybody knows what the V is, I think already. It's voltage. Voltage V, which stands for volts. And then you get the power, which is power measured in W or watts. Okay? So watts of power. Over here, we'll talk about this one in a second. So here's a quick sample problem. If I'm asking you for power of electrical power, you have to have two things. I have to tell you that, let's say there's a wire, and I have to tell you that, sorry, there's a little wire here. There might be a little resistor, and there might be a battery. There should be a battery of some sort. And if the voltage is, let's say, 12 volts, and the current is equal to, let's say, 5 amps of current, then that's the two things you need to know: voltage and current. So P, electrical P, is equal to I times V. So PE is power electrical is equal to I, 5 amps, times voltage, 12 volts. And this particular electrical schematic, this little drawing, with this much current and this much voltage, would be 5 times 12, so it'd be 60 watts of power. What that really means is that that's how much energy per second is traveling out of the battery. Um, 1 watt is the same as 1 joule per second. A joule is a certain amount of energy. So, there's different units for energy like calories and joules and whatnot. So, 1 joule traveling per second, or like 1 joule being used per second, I should say, is 1 watt. So that means this electrical thing is using 60 joules per second. Although, we don't need to worry too much about that as of right now. Just know that the electrical power of this thing is 60 watts. So mechanical power. That brings us to mechanical power. Mechanical power, you need to know three things. Okay, so mechanical power. I'll put P and I'll just put an M here so we know it's mechanical power. Is equal to mgh divided by T. Now, there's different ways to look at this, and there's different ways to write this equation. But the point of this is mechanical power is how fast you can do work. So in this work we're talking about is simply lifting something. So if I were to lift a weight, if I could take more weight and lift it even faster, I'd be more powerful, right? It'd be more power. So that's why we have a few things. I need to know how fast I'm doing it. So time in seconds, with an S. And then I need to know how high are you lifting it? Height in meters. So you'll see an M. And then and How massive is the thing you're lifting in kilograms? And that's kilograms, by the way. Now, what is the G? What's the G? The G is equal to this, folks. Please note this. G is always 9.8. Okay? Its unit is meters per second squared. That's the gravity on Earth. So this one, the problems will not give you that because they're going to assume everything's on Earth. It's still important though, because think about it. If I were lifting weight, if I was lifting 100 kilograms of weight and I could lift it in 1.2 seconds, raw, and lift it right over my head, you'd be like, Mr. Swanson's pretty powerful. He's got a lot of power. He can do lots of power because he can lift all that mass. So he can lift all this mass and he can lift it all the way to the top of his head, 2 meters high, and he can do it like in 1.2 seconds, on Earth. Of course, G is 9.8, right? So Mr. Swanson's very powerful. But, however, if this was done on the moon, if I lifted all that weight on the moon, you may not be impressed. You'd be like, Mr. Swanson lifted 100 kilograms right over the top of his head in like 1.2 seconds. And you're like, oh, he did that? He must be really strong. And then you're like, he's like super powerful. He's got a lot of power. And then you're like, well, he did it on the moon, though. And you're like, oh, well, the moon, it's easy to lift stuff, because the gravity is weak. So that's why gravity is kind of important here. So let's say, if we could, let me see if I can slide this down and get a little room here. There we go. Let's say we lift something up. Let's say the mass is equal to, let's say I'm going to lift something big. Let's say 50 kilograms. That's pretty heavy. That's heavier than my son. That's a lot. That's like over 100 pounds. So I lift that much kilograms, and I lift it over my head, which is about 2.0 meters. So 2.0 meters. And what else do I need to know up here? I need to know the mass. I gave that to you. I need to know the height. I gave that to you. G, we already know it. It's 9.8. It's as long as we're doing this on Earth. And then I need to tell you how much time it took me to lift this, right? So time, I do a big quick power lift. I did it like in 1.2 seconds. Or, probably could have even done it faster. So how much power is this? So mechanical power is equal to mgh over t. And so let's do this. Mass is 50 times 9.8 times height, 2, divided by 1.2. Now the first thing we're going to do is multiply all across the top. So we're going to go ahead and we're going to get a calculator because, that makes it easier. Here we go. And so we get 50 times 9.8 is 490. Then times it by the 2.0. And that's 980. So we get 980 on top. So let me do that. Divided by the 1.2 on the bottom, right? There's that 1.2 still on the bottom. I got to deal with that next. So let's divide all that 980, divide it by 1.2. And it's 816.666, so I'll just say 816. 816 watts of power. And that's a lot. I mean, that's a lot for a human. Just to let you know, if you can do 746 watts, that's a horsepower. That's 1 horsepower. You guys heard of horsepower? Like, oh my, this car's got 120 horsepower or 400 horsepower. It's an old unit of measurement, horsepower. Sometimes people are ridiculous and they keep using horsepower, which is like an old unit to measure new things. Like, oh, that spaceship has 2.3 million horsepower. You're like, okay, stop measuring our space shuttles with horsepower. Like how much horse can do. So if you can do 816 watts of power, that's pretty good. That's a little bit over a horsepower. And yes, a human is able to do that. Not for a long time. You couldn't do that for a long time. You could do it for like a second or a minute maybe, but you couldn't do 816 watts of power like for like an hour. No way. I mean, you'd be like a Superman if you could do that. But most humans, even you folks, might be able to pull off 816 watts of power, but just for a few seconds. Then you would be really, really tired. All right, and that's about it.